Alright, let's give this one more shot. We're going to try to figure out how to solve rational equations and inequalities. First of all, let's try a simple rational equation like x over x minus 6 equals 1 over x minus 4. Now, I did this one in class for some of you, and some of you have noticed it, saw it. So if you already know how to do this, that's fine. Just bear with us. You cross multiply here, of course. It's like anything else. You cross multiply. X minus 6 times 1 equals x minus 6. And then x times x minus 4. So x times x minus 4. And so this, of course, is going to be x squared minus 4x. And this is x minus 6. And so if I subtract x from both sides, I get negative 6 equals x squared minus 5x. And I add 6, and I have 0 equals x squared minus 5x plus 6. Now, there's no big deal here. This is a standard quadratic equation. We've been doing this for a while now. So, and this one factors very nicely. X minus 2 and x minus 3. Okay, so equals 0. So that means x minus 2 equals 0, or x minus 3 equals 0. Add 3, x equals 3. Add 2, x equals 2. Alright, so there's one thing we can do. And let's try another one here. We've got x over x minus 3 plus 2x over x plus 3 equals 18 over x squared minus 9. Now, I'm going to make a note right now before we start doing anything. We're going to note our domain restrictions. You notice that x cannot equal 3 or negative 3 in any of these, okay? So we're going to say first, x cannot equal 3 or negative 3. Those two are excluded values, okay? And so we're going to multiply the both sides here by x squared minus 9 and x squared minus 9. Now, x squared minus 9 is equal to x plus 3, x minus 3. And so, obviously, that cancels, this one cancels out with one of those factors. And so we're left with x times x plus 3, the other factor. This one canceled with one of these, okay? Remember, this is x plus 3. That's a goofy looking 3. And x minus 3. So we just canceled this one with this one. So we're left with x plus 3 times x, which is what I have here, plus 2x times x minus 3. And that's the same thing I did here, except it's the other factor. X plus 3 cancels with x plus 3. And so I'm left with x minus 3 times 2x. And of course on the right side, this cancels with this, and so I'm left with 18. And if you need to stop the video right now and figure that out and work through that, that's fine, we can do that. But we can even erase this unnecessary point. So we've got x times x is x squared, plus x times 3 is 3x, plus 2x times x is 2x squared. 2x times negative 3 is a negative 6x, and that equals 18. And all I'm doing now, there's nothing fancy that I'm doing now. This was the only fancy stuff we did, going from here to here. Now it's just pure algebra. X squared plus 2x squared is 3x squared. That's this one plus this one, okay? And then 3x minus 6x is minus 3x, and that equals 18. But, of course, if I subtract 18 from both sides, I get 0, okay? 3x squared minus 3x minus 18 equals 0. If I take 3 out of this, I have x squared minus x minus 6 equals 0. I have 3 times x minus 3, x plus 2 equals 0. So, scrolling down a little bit, we say 3 cannot equal 0. So one of these two has to equal 0 in order for this equation to be work. Okay? So I'm going to say x minus 3 equals 0. So x equals 3. Or x plus 2 equals 0. So x equals negative 2. Now, remember that thing we talked about up here? Extraneous solutions. X cannot equal 3. That's one of my things that I can't equal. So that means that my solution is x equals negative 2. Now we're going to show you how to do the same thing, or something similar, on a calculator. Now before I put this into my calculator, okay, let me rewrite the original equation that I started with. Okay, the original equation was x over x minus 3 plus 2x over x plus 3 equals 18 over x squared minus 9. Now if I graph this is equal to y1 and this is equal to y2, and find the intersection, that's normally the way I would use my calculator to solve something like this. However, that would be unnecessarily complicated. So I'm just going to subtract 18 over x squared minus 9 from both sides. And so I get x over x minus 3 plus 2x over x plus 3 minus 18 over x squared minus 9 equals 0, because these two cancel out. Okay, so now I can put that into my calculator. And let's see if we can get that. And this is going to be kind of tricky because remember we got some of you, I know you get it's called pretty print. That's what Texas Instruments called it. And that's where you can actually type in the fractions like this. And if you can do that, if you got a TI-84, you can probably do that. But we don't have that. So let's see what we can do here. We got parentheses, another parenthesis, or actually I don't need another parentheses. X divided by parentheses x minus 3, close parentheses, another close parentheses. Now, this was in parentheses here, okay? And the whole thing is in parentheses, all right? So just to clarify what I'm doing there, plus parentheses 2x divided by parentheses x plus 3, close, close. Now you say, why didn't I use parentheses up here or up here? It's because I've got one term. Okay, down here we've got x plus 3, so that's two terms. So that's why I need the parentheses. Okay, and then minus and parentheses 1, 8 divided by parentheses x squared minus 9, parentheses, parentheses. And graph that bad boy. And now we're going to look for where the graph crosses the x-axis, because remember now we've set these three terms now are equal to 0. These three radical terms are equal to 0. So we're going to see where they crosses. Now if you look, you notice that at x equals 3, okay, if we trace this thing and we go to x equals 3, enter, there's no corresponding value for y. So there is definitely a hole in the graph at x equals 3, but there is no 0. There's no y-intercept, or x-intercept rather, at x equals 3. But when we go to x equals negative 2, and I put two negatives on there, so two negatives don't make a positive, Or, well, do they? Go to, let's see what I did. Ah, that's what I did. I put 3 negatives there. So I put -2 in, enter, and sure enough, y equals 0. So my one intersection with the x-axis is right there at y equals x equals -2. So that's my solution to that one. Let's try another one. And I will get this in a moment. Okay, there we go. So let's try another one. This time we're going to do an inequality. Okay, an inequality is something like this: x over 2x minus 1 is less than or equal to 1. Okay, so algebraically, and this is where it's tricky doing inequalities like this. Now, if I had, I'm going to do it over here. Suppose I had x over 2x minus 1 equals 1. Well, the easiest thing to do, of course, 2x minus 1, 2x minus 1. And so I'd have x equal to 2x minus 1, because these two cancel and leave me with x, okay? So 1 times 2x minus 1. And of course, it's pretty simple from there. You subtract x, add 1, and you have 1 equals x, okay? So that's the way we'd do it over here if that were an equal sign. But it's not an equal sign, but we're still going to multiply by 2x minus 1 on both sides. The problem is, I don't know if 2x minus 1 is greater than 0 or 2x minus 1 is less than 0. Because you see, if it's greater than 0, then I can just continue just like I did over here, and I'm all set. If it's less than 0, I have to reverse the sign because of my negative rule. Well, since I don't know what x is, I don't know if 2x minus 1 is greater than 0 or less than 0. So let's work it out 2 different ways. Let's see it's greater than 0. So that I multiply 2x times, and I have x, just like over here. I have x is less than or equal to 2x minus 1. So I add 1 to both sides, and I did it kind of quick over here, so it might have confused you, but add 1 to both sides. You have x plus 1 less than or equal to 2x. Then subtract x, and 1 is less than or equal to x, or as I like to put it, x is greater than or equal to 1. Okay? X is greater than or equal to 1. But don't forget about this restriction here. So we have to figure that in there too. So we have to say, move down a little bit. There we go. 2x minus 1 is greater than 0. Add 1. 2x is greater than 1. Okay? And divide by 2. So x has to be greater than 1/2 also. So it has to meet both of these conditions. Okay? So since everything that's greater than or equal to 1 is also going to be greater than 1/2, I don't have to worry about that right now. But I probably will have to worry about that in the next one. So we can't just skip this and say don't worry about that. Okay? So let's try this other one over here. We got 2x minus 1 is less than 0. So that means that when I do this, 2x minus 1 times both sides, then I have to switch the signs. Okay? So that means that I have x is greater than or equal to 2x minus 1. Okay? And so that means that add 1, x plus 1 greater than or equal to 2x, subtract x, 1 greater than or equal to x, or turning that around like I did on the other one, I've got x less than or equal to 1. So, what about this other doodad here? This other constraint that I have is 2x minus 1 is less than 0. Okay? So, 2x is less than 1. X is less than 1/2. So x has to be less than or equal to 1. It also has to be less than 1/2. Well, If it's less than 1/2, it'll be less than or equal to 1, won't it? So this is the one I have to use right here. And so those are my two, this is my solution, or these are my solutions. I put these together, okay, and I end up with x greater than or equal to 1 and less than 1/2. So this is a compound inequality. So it's going to be on the number line. Oops. Back up there. On the number, oh yes, that's a nice pretty number line. Okay. So I got 0, 1. By the way, these are arrows both ends. And 1/2. So I've got an open circle at x equals 1/2. And I go that way, okay? And I've got a closed circle at x equals 1, and I go that way. Okay? So now let's take a look at this on the graph and see what that looks like. Okay. So again, and let me put that graph away again. Remember that in this one here, this is relatively simple. So what I can do is I can graph this, I can make this one y1, and I can make x equals 1, or y equals 1, y2. Okay, so let's see what that looks like on my graphing calculator. And get rid of all this nice fancy stuff that I took so long to put in there. And let's put this, get this up here, and x divided by parentheses 2x minus 1. If you guys are confused at all about why I use parentheses here, I can stop and explain that. But okay, and x equals 1. So I graphed this thing. Now, there's that graph, and there's a graph of x equals 1. Let me zoom in square on this. I'm going to go zoom box, okay, and so go over here and up here just above here and hit enter, go over here and down here and enter, and forget this asymptote in the middle here, and I look at this intersection here, okay, trace, and let's make that x equals 1. Okay. And there's x equals 1 and y equals 1. So you see from here, the curved graph, which is the graph of the one on the left, that's below this line of x equals. So that means that the value for this is less than or equal to the value for this. Okay. And looking to the left here, negative 0.5. No, I'm sorry. 0.5, not negative 0.5. Enter. Okay. And I don't see a value for y there, so that's this right here. How about negative, or 0.499999999? Sure enough, there's a value. And it's very, very small, so it's way down here. So you see where the graph is coming up from this asymptote here, which is, the asymptote is x equals 1/2. And so the graph is coming up from, so at every point on that graph, and if we zoom out again where we were before, and okay, you see the line x equal, or y equals 1 right here? You see all of this stuff is below that line, okay? So I start right about here, because to the right of x equals 1, there's no value for y that's below this line. Or that, yeah, that's below this line. So, and again, I probably have to stop and explain that a little bit. It's kind of a complicated concept, but this is how you can use your graph to figure out these things. And yes, this is kind of a long video, and I'm sorry for that, but this stuff had to be explained. And so this next one, I'm just going to go right straight to the book because the book does a real good job of explaining it step by step. We're going to solve this thing up here, which is x minus 2 over 2 quantity x minus 3 is greater than x over x plus 3. Now, in order to clear the inequality of fractions, you have to multiply each side by the lowest common denominator. 2 times x minus 3 times x plus 3. So that means that there are 4 possible cases, okay? X minus 3 and x plus 3 are 2 different terms or factors there. And either one can be positive and either one can be negative. So you got 4 different cases. And notice what it says here: the algebraic method of solution is beyond the scope of this textbook. It's also beyond the scope of your algebra teacher right now. So all we have to do though is we can subtract x over x plus 3 and then take a look at our graph. And we can go through that step by step. But the point is, using your graph and your table, it's fairly simple. You got 2 ranges that are solutions there. And so that's all there is to it, and now we can probably get some things done. Thanks.